Hi everyone, today's lesson is really going to be about end behavior and graphing. We've worked with large polynomials and we've been breaking them down so that we could find the zeros of it. But what's the point about finding the zeros? Great, zeros are wonderful, but why do we do it? Now, today we're going to talk about how useful are these zeros, and what I'm going to do right now is I'm going to show you guys a couple of graphs and I'm going to predict a couple things for you, okay? So let's look at some easy ones first. Let's give myself a problem that says this. Okay, here is my graph. My graph is f of x is negative 2x cubed plus 3x squared minus x. Okay. I'm going to give you some fast forward skills. We're going to be able to factor this, take that out. We have negative 2x squared plus 3x minus 1. We can then factor this out again. 2 and 1, 1 and 1. You can throw the negative out if you want. I think if you take out the negative, it would be a little easier. If I write negative x, 2x squared minus 3x plus 1. I think that's going to be a lot easier for us. 2, 1, 1, and 1, 2x, x, put a negative in the front, and we have 1 and 1, positive, sorry, negative, negative. Negative, negative? Yes, negative, 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 and negative. So, we've spent a little bit of time factoring the problem so that we can find the factored version. From the factored version, we can say the zeros of the graph is 0, 1 over 2, and 1. Please make sure you are okay with these skills. Right? Again, what we did was we factored it. In this case, I just took out the x. Not too terrible. I then, since it was x squared, I was able to factor that from algebra 1 and algebra 2. And we end up with these zeros. Now, what do we do with these zeros? Well, here is this idea. At f at 0, if I plug in x at 0, my y value is 0. At f at 1/2, my y value is 0. These are my y values, okay? At f at 1, my y value is 0. Okay? Now, if I'm graphing this from left, let's plug in the numbers. This is 0. Call this 1/2. And 1, we have, these are my zeros of this graph. Okay? Now, I could then plug in every value in between here to figure out what the graph looks like. But I today will show you the super fast skill of how to graph this equation in a matter of seconds once you have the roots. Okay, once you have the roots, roots. I can tell you we can graph this in a matter of seconds. No joke, seconds. So here we go. I'm going to ask you, what number is past the number 1? Isn't it like 2, 3, 4, 5? Aren't all these numbers bigger than 1? What number is before 0? Isn't it negative 1, negative 2, negative 3? So what happens is we're going to look at end behavior here. What happens after the graph and what happens before the graph? And how do we know this? And why are we guaranteed to do this? So here is the trick. Here's a simple trick. We know that there's a 0 at 0, 1/2, and 1. How do we know this? Is because we got this from our answer right here. For sure. These are our checkpoints. If you guys ever play a video game and they have checkpoints for you, go to this point A. After this point A, you go to point B. After this point B, you have to go point C. And if you don't go through those points, the game doesn't progress. The same thing happens here. We're going to walk through this graph in some type of way that we have to cross through these checkpoints. Well, what's the difference between this graph here, me crossing this way, versus me crossing this way, going the other way? Right? What about if this graph was higher? What if it goes up and down and up? How do I know it's not that graph? There's a infinite many set of possibilities. But you know what? With a little amount of work I'm willing to put in here, I'm going to show you guys that we can graph this again in seconds. Now, and this graph will be good enough. here we go. Our first problem is, take a look at this. Negative 2x cubed versus 3x squared versus x. Who here is the biggest bully? Who is the biggest influencer? The x cubed, the x squared, or the simple x? You would probably agree with me that the biggest bully, the biggest changer here is x cubed. So I'm going to make this problem simply just look like negative 2x cubed. That's what we're going to look at. And for all these problems, this is what we do. Negative 2x cubed. So that 3, very good, it's a cube. Now my question is this. If I plug in a big number like 100, is 100 cubed a big number? It is, right? And is 100 cubed times negative 2 going to be a negative number? Let's pick a smaller number. Even if I pick 10, that would still be a big negative number. Negative 2 times 10 cubed is negative 2,000. Right? That's a negative number. What if I pick 9, 8, 7, 6, 5, 4, 3, 2, 1? X cubed will still be the biggest bully here. So here's what my trick is. Anything after my last 0, take a look, this is my last 0. If my front coefficient tells me a big number would be negative, this graph must go down. That's end behavior. Now, let me say this again. Why do I know this? Because if I plug in a big number, something times something times something, and make it negative, hey, won't that be a negative number? So I can guarantee you that this graph will eventually go downward. Let's go on the left side. Aren't all these numbers here negative? And as we keep going, it becomes more negative. So you give me a big negative number and plug it into x cubed. What's a negative times a negative times a negative, folks? A negative times a negative times negative is negative, right? But now take that negative number times another negative. A negative, negative, negative times another negative is a positive. This graph has to go up here. Now, I'm going to illustrate that in a different way now. Please take a look at our factored version. Again, this is just another demonstration. Equals negative x, 2x minus 1, and x minus 1. Okay? If I plug in a positive, remember how we said 10 was going to be a huge number? If I plug in a positive 10, 10, 10, I don't want you to do the math. I need you to tell me if it's going to be a positive number or a negative number only. Negative 10, that's a negative, right? Who's going to win? The 20 minus 1? Is it 20 or the 1? So the 20 is going to win. So this is going to be positive. How about the 10 minus 1? This is positive, right? What's a negative times positive times positive? This is going to be a negative answer. We know it's going to be someplace down here. We don't know how far. We're not willing to do the work. Don't do the work. But we can say as x gets closer to positive infinity, as x gets closer to positive infinity, y gets closer to negative infinity. Because it's heading down to hell. Or negative infinity. Okay, so as the number gets bigger. Now, here is the crazy part. When do we know it's starting to become more negative? It happens right after the 0. If I can convince you that the last 0 on the right side of the graph is 1, I can bet you that any number after 1 will be negative. It will forever be negative for the rest of its life. It is a loser. Let's try it. If I plug in the number 2, let's say I'm looking at the number 2. Plug in 2, 2, 2, and tell me if that number is going to be positive or negative. After you do that, try 3, 3, 3, 3, and see if that makes any difference, if it'll still be negative. Remember, you're not solving it, you're just telling me the signs. So for 2, isn't that negative? 2 times 2 is 4. 4 minus 1 is still negative. Oh, it's positive. 2 minus 1 is positive. Don't we still end up with a negative number? What if I pick, let's give you guys another one. Now, what if I pick 1.1? Is it 1.1 on the right side of 1? 1.1, 1.1, 1.1. That's if we end up with the same results. If I plug in 1.1, that's going to be negative, right? Is 1.1 bigger than negative 1? Yep, that's going to be positive. 1.1 bigger than negative 1? Yep, that's going to be positive. Oh, sorry, this was 2.2. Do you agree that it's still going to be negative? On the left side, give me any number that's less than 0. Why did I say 0? Isn't 0 my most left 0? See, 0 is my most left 0, okay? So on the left side of this, let's give ourselves a number. Let's pick negative 1. Okay, if I pick negative 1, will the graph be on top or on bottom? It looks like my guess was on top. I'm going to prove that to you. Let's plug in negative 1 here. Plug in negative 1, negative 1, negative 1. And we'll see what the signs turn out to be. Remember, you're not really doing the math. Please don't actually multiply it. But please look at the signs. Because I don't care what the value is. I just care if it's going to be on top of the graph or below the graph. Here we go. A negative and negative become a positive. You guys okay with that? Negative 2 minus 1 is negative. Are you guys okay with negative 2 minus 1 is negative 2 minus 1 is negative 3? Just to say negative, just say negative. How about what's a negative 1 minus 1? Is that positive or negative? And what's a positive times negative? We end up with a positive. That's why we're up here. That's why we're up here. What if I pick negative 10? We're going to get the same exact results. The answer will eventually be positive. It might be a huge positive number, but I don't care. So now that we looked at this graph and we say, you know what, I at least know the beginning and the end. Let me go back and review how I did it so quickly before. So once I find the roots, let me go erase all this junk up here. Okay, once I find the roots were 0, 1/2, and 1. Everyone take a look. I graph 0, 1/2, and 1. Easy peasy. Graph the roots. Look at the rightmost root. What's the end behavior? What is the end behavior? And just like this, just like bookends, we have two ends. We have a left end and a right end. So on the right end, this end is going to go to infinity as x gets closer to positive infinity. As x gets going bigger, which way is the graph going to head? And the trick is this now. After you are done with graphing the roots, just go back and look at the boss. And ask yourself a simple question. If I did pick a big positive number here, just write the positive sign. What is a positive times a positive times a positive? It stays positive. Now, what's that positive number times a negative? We know for sure that's going to be a negative now. On the other side, we're going to do this a couple times so you guys can see the pattern. What if I plug in a negative number? Plug in a negative number here. What's a negative cubed? Negative, negative, negative is still negative. And we multiply this by a negative, which means all these numbers on the left side will be positive forever. Then the next question is, Mr. Chico, how can you guarantee that this graph doesn't sneak back in? Why doesn't it sneak back in across the border? Okay, across this y-axis. Oh, sorry, the x-axis. The x-axis is because in order to cross over, don't we need a root? And that's the thing about this graph. I already told you where the zeros are. The zeros can only happen at 0, 1/2, and 1. These are my only zeros. How can you sneak back over if that is not a 0? There are no more zeros here. So one thing I can guarantee you is this. Once you're under the ice, you're never coming back up. Which makes me think of a terrible, terrible, terrible story. You guys ever watch movies where people are playing on ice? And then there's like, the ice breaks and a hole happens and the person falls in? And then the person ends up swimming underneath the ice. He's trying to get out. But guess what? He's under the ice, isn't he? How can he come back out of the ice? He can't. The only way out is back through the root. And that's what happens here. Once we end up underneath the ice, we can't come back up because there are no more roots. So I can guarantee you, once you're down, you're down. Okay. How about if you're on top of the ice? If you're on top of the ice, aren't you just nicely on top of it, right? And the only way down is through a hole. In this case, we don't call these holes, we call these roots. Okay? So once you're floating on top. Now, let me finish this next part. Here is the trick. And this is going to be important for us a little bit later. Every time you see a root, you cross. You must cross over. You must cross over. You must cross over. Now, this adds an extra rule. Whenever I see a root, I must cross. Okay, whenever I see a root, I must cross. But there is an addition to that. It's actually about what we call multiplicities. Remember multiplicities we talked about on our last homework? What if the answer happens twice? What happens if the answer happens 3 times, 4 times? And actually that's super important because multiplicities tell us, do we cross or do we bounce? Now, let me go ahead and give you guys an example of this. If I write f of x is equal to x to the 5th, not x to the 5th, let's do something easy, x cubed plus blah, blah, blah. I don't care what's here. It's actually just fluff. If I tell you the roots are x equals to, let's do -1, 0, and 1. Let's make it pretty easy. So we can start with this graph. So we have roots for sure. So that means we have holes at -1, 0, and 1. -1, 0, and 1. So I can guarantee you that we are going to break through the ice at these points. Okay? We have enough to graph now. We have enough to graph. So all graphs that look like this, right? We can graph it like this, just with the roots, because I told you these are the points that you must hit. Have you guys ever been to the mall with your family and your parents say, meet back here at 6, right? It's 3 o'clock now in front of Macy's. Come back here at 6. Those are your 2 routes. You enter the mall at 3 at Macy's, and you better leave through the mall at Macy's at 6. You better be here. We better be at the roots, -1, 0, and 1. All right? So what does the graph look like at the end behavior? Well, all you have to do now is look at the front guy, the biggest bully. If I give you a huge positive number, 10, what's 10 times 10 times 10, right? What is positive times positive times positive? It will stay positive. I guarantee you this graph will be up. They shout out your name. Brian! Get your butt over here. We're leaving. Okay, on the left side, aren't all these numbers negative? What's a negative times negative times negative? It stays negative. Bam, you're down here, you're stuck. And what do we say about roots? We have to cross them. We have to cross from left to right. Okay, from left to right, da, 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 left to right, left to right. We have to do something like that. We cross only at the roots. Only cross, only cross, only cross. Now, you might be saying, Mr. Ko, how can you guarantee me this is what the graph will look like? Actually, I can't. What I can guarantee you is this is the shape. I can't guarantee you it's exactly like 1. This could be way higher. This could be way lower. This could be way flatter. But what happens is we at least have an idea of what the graph will look like in these different phases. It's almost like phases of life. I can tell you what you're going to look like while you're in elementary school. I can say what you look like in middle school. I can say what you look like in high school, but I can't really predict what's going to happen later. Okay, so let me predict this. Just to talk about this. If I was trying to make a prediction between -1 and 0, you're going to be positive for sure. Between 0 and 1, for sure you're going to be negative. After 1, I can guarantee you'll be positive forever. Before -1, I can guarantee you'll be negative. Okay, so let's go back and look at my my first example to see, does my graph really look like this? Does it look like what I guessed it was going to look like here? Okay, so let's go ahead and just pull on Desmos. Oops, wrong one. Desmos right here. Now I'm going to go ahead and graph this graph. I'm going to say new negative 2x cubed. Oh, darn it, wrong one. X cubed plus 3x squared minus x. And if you take a look at this graph, wait, oops, I lost one. I lost a 3. Now, if you take a look at their graph and take a look at my graph, pretty darn the same thing, right? You guys know what I'm saying? Pretty good. Pretty darn good. Did I know that this graph will actually hit 0.096? No, I don't need to know that. That's not to the level that we're graphing at. We're just saying, hey, look, it's above the line. Okay, it's above the line here. All I care is that it's above the line, and we are above the line. Over here, it's below the line. It's below the line. As x is left of 0, we shoot off to infinity. Shoot off to infinity. And on the right of 1, we shoot down to negative infinity. We shoot down to negative infinity. We pretty much modeled this graph. Okay? And that's like the goal of us factoring and finding roots. In the end, it allows us to figure out, hey, what does this graph kind of look like with the information that we were able to deduce? Now, let me go ahead and talk about this next rule. Are we going to see this graph? You guys will not be really seeing too many graphs on MyOpenMath, but you guys are going to talk about the behavior. What happens to this graph as we go to infinity? And I'll demonstrate that in MyOpenMath coming up. If we were in the classroom, we'd be graphing this like crazy. But it's hard to graph and have you guys check the graph on MyOpenMath. I feel like maybe we can do an IXL. No, we can do a kudos off. And I can have you guys just print it and graph it and then take a picture of it. We could do that also. And maybe that might be a good idea to do. So, but we'll worry about that later. Let me give you another problem here. This one is a huge one. X to the 5th. Oh wait, we did this one, right? Oh, my bad. Wait, did we? No. We're looking at... Okay, let's do this one. X to the 5th plus 6x to the 4th plus 12x cubed plus 8x squared. Okay, this is some crazy expensive graph. I'm going to tell you this. We have zeros. Our roots are 0 and negative 2. Turns out we only have 2 roots, but we have a different multiplicity. We have a multiplicity of 2 for x equals to 0 and a multiplicity of 3 for x equals to negative 2. Now, how would I find these roots? I probably would have done synthetic division. I would have factored it and done synthetic division. I would have found that my answers would be only 0 and 2, only 2 roots. And now this is where we're going to talk about multiplicity. What if the numbers repeat? And how does that graph play out? When I said before, if we have a root, you're going to just cross it, you're going to cross it, you're going to cross it. Every time I see a root, it's a time where you just cross to the gate. You guys ever go through Disneyland and you enter the gate? Yes, I'm in the most wonderful place in the world. And then when you leave, you're like, oh, I'm back in the parking lot. So every time you cross we can only cross at the roots, and when you cross, you go right on through to the other side. But if we have multiplicity, it changes the story a little bit. What if the answer repeats more than once? And I will show you guys what this graph looks like. Let's go ahead and graph the roots at 0 and at negative 2. Okay, 0 and negative 2. Now, right now, I can guarantee end behavior. What does the graph look like on the right and on the left? Okay, so as x, right, this is x, right? X is positive infinity. X is negative infinity. So on the right side, as x goes to positive infinity, where does y go? Where does y go? Does y go to plus or minus infinity? Is this going to shoot up or shoot down? Okay, so all these polynomials have to go either to infinity or negative infinity. So let's go back and look at the original problem. We know that numbers on the right are all positive, aren't they? So what is a positive times a positive times a positive times a positive times a positive? Remember, this is my biggest bully. He's like the patriarch of the family. He just tells us where to freaking go. What about my opinion? What about my opinion? Well, you know what? I don't give a crap. I'm paying the bills. So x to the 5th says, hey, what's a positive times positive times positive positive? That's going to be positive. So I can guarantee you this. Please take a look. On the right side, after my last root, we must go to infinity. Okay, again, how did I do that? I said numbers here are all positive. These are all positive. And what's a positive, 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 positive? We multiply them together to become a positive number. Let's go to the left. The left here is going to be negative. See, aren't all these numbers after the root, aren't these all negative? Right, after the root, it's all going to be negative. Okay, so what's a negative times negative times negative times negative times negative? That stays negative. Guarantee it's going to come down. I have the outline of this graph now. Let's go ahead and look at this on Desmos just to start, just to show you I'm not bluffing. Oops, this one. Okay, I'm going to write the problem. It's going to be x to the 5th plus. So while I'm doing this, you guys can catch up copying the notes. If you have any questions, darn it. X to the 5th plus 6. Darn it, the 6 didn't come out. Plus 12x to the 3rd plus 8x squared. All right. If you take a look at the graph that we have here, that looks a little bit tweaky, but you can agree with me. On the right side, we do go up. Right on the right side, we do go up. We do go up on the right, and we go down on the left. All right, we got at least the end behavior right. So I want to write this to make sure this part makes sense, and this is what you're going to be asked to do on My Open Math. They're going to ask you, hey, as x goes to infinity, as x goes right, which way does y go? Y goes to positive infinity, because y is going to shoot up to positive infinity, just like what we were hoping GameStop was going to go, to infinity. What happens when x goes to negative infinity? What happens when x goes to the left? See, x is going to the left. Where does y go? Does y go up or go down? Y goes to negative infinity, because it's starting to tank, like GameStop today. Now, here's the next part. Before we said, every time you have a root, you have to cross. You have to cross and you have to cross. But take a look. If I cross that way, I'm heading in the wrong direction, right? Didn't we say we had to go up? And it's because multiplicity is the easiest way to graph. Like, no joke. Easiest way to graph. So here's the rule. If the multiplicity is even, you bounce. You bounce off the root. If the multiplicity is odd, you cross the root. Okay? If the multiplicity is even, we bounce. If the multiplicity is odd, we cross. What do I mean by bouncing? What do I mean by crossing? I mean, when you bounce, take a look, like a ball bouncing. Oh, bounce. This is a bounce. What if I'm coming from below? Whoops. What if I'm coming from below? Oh, bounce. This is a bounce. It's almost like the poor guy who was stuck underneath the ice. He can't get through. It's a bounce. You're on top of the ice, bounce. You can't break onto the other side. You can't break onto Rich. Okay? So when the multiplicity is even, we bounce. And when the multiplicity is odd, we cross. A cross looks like this. Whoops. Here's my root. We go ahead and we cross over. Whoop, darn it, missed it. We cross over. If this is my root, we cross right on through. So, having this basic idea of what multiplicity does, let's go back and take a look. At 2, please review this. At 0, what is the multiplicity at 0? The multiplicity is 2. So if it's even, see, isn't 2 even? This is even. Are we going to cross or bounce at 0? We said if it's even, we bounce. Take a look. As we start walking, look, do you see I'm walking up as I get closer to 0? Whoops, sorry. Actually, you know what? That's right here. Okay, but you know what? That's work on. Whoops. I should have done -2 first. -2 first. Let's do -2. -2 is the earlier part of the story. At -2, our multiplicity is what? 3, right? Is that odd or even? It's odd, so we cross. So the trick is we're going to cross at -2. Here we go. As we're climbing, getting rich. And at -2, this is -2 here, we get to break on through. Yeah! Woo! I'm like a dolphin. Like a dolphin, right? How can I draw a dolphin? Like a dolphin, right? So, whoa, look at the dolphin soar through the air. It broke out of the water. Where's the next point that dolphin has to hit? The line has to go to 1, right? Sorry, has to go to 0. Oh my gosh. Breaks through -2, has to go to 0. At 0, we just made a big deal of it. 0 is an even multiplicity. So for even, do we bounce or do we cross? We bounce. And take a look. We didn't cross over. We bounced and we ended up heading in that same direction. So let's go back and tell the story. I'm going to go ahead and start from scratch. Everything we know we have. Okay, here we go. We have roots at -2 and 0. Good job, Mr. Ko. What does the end behavior look like? What's a positive to the 5th power? Positive stays positive. Here we go. You got to go up. On the left, negative. What's negative to the 5th power? Oh, that's still negative. So on the left side, we have to go down. Okay. So as this goes to positive infinity, we stay positive. As it goes to negative infinity, we stay negative. Now, what does the graph look like? Does it just randomly cross? Right? What happens in between? So we walk it. As we're walking, walk. At my first checkpoint at -2, is -2 a odd or even? -2 is, the multiplicity is odd. And for odd, we cross. Thank you very much, sir. I will see you later. We have to cross all the way to 0. At 0, do we cross or do we bounce? We said at 0, the multiplicity is 2. We bounce. So we went boing. Again, we went boing, 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 boing. It bounced off the root, and we're headed the same way. So a question someone asked is, how do I find the roots so fast? In this one, I actually gave you guys the roots. Okay. If I wanted to find the roots, we could have done it, but I found the roots here. I gave you guys the roots. Okay. So this is what I wanted to point out, is that these graphing problems are all dependent on the roots. Now let's go ahead and give ourselves another problem here. Okay, and then we'll start afresh. My problem is f of x is equal to -x to the 4th plus 7x cubed minus 18x squared plus 20x minus 8. Don't you hate this? This is terrible, right? Terrible. I'm going to tell you the roots though. The roots are 2, 2, 2, and 1. Or you can write the roots are x equals to 2 and 1. But careful, 2, x equals to 2 with a multiplicity of 3, and x equals to 1 with a multiplicity of 1 only. So please take a look here. We could have found the roots by doing synthetic division. But that's not the lesson today. The lesson is just graphing it. Okay, here we go. We have roots at 1 and 2. That's our roots. That's it. Okay, all right. So once we found the roots, let's go ahead and graph the roots. Next thing we work on is end behavior. End behavior. So let's write it. 1 is roots. 2 is end behavior. And 3 is journey. Journey. The 3 is finishing up the graph. Okay, finish the graph. Sorry, my writing's terrible. Okay, so end behavior. Look on the right. Isn't this eventually going to all be positive? So what is a plug a positive here? Everyone look, plug a positive here. Plug a positive. What's a positive times positive times positive times positive? Remember, we're looking at the biggest bully here. A positive, positive, positive. It's still positive, but don't forget there's a negative in front. So positive, 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 positive. Positive times a negative. You are going down. Do I need a calculator for that? No, please don't use a calculator. But make sure you understand a positive, 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 positive. It's going to be positive, but that negative forced it to be flipped, going down. On the left side, let's pick negatives. Over here we have negative values, right? All these negatives eventually. Mr. Cope, it's positive here. Ignore that. Just keep walking, and eventually you're going to be negative. What's a negative? What's a negative times negative times negative times negative? But don't forget, there's a negative in the front, right? That negative is this negative. That's going to be negative. You're also going down. So what does this graph look like? Well, if we just cross, hey, great, we're there. But I want to make sure you guys are cool with y. If I wrote look at 1 here. What is the multiplicity at the root 1? The multiplicity is 1. Do we cross or we bounce when it's odd? It's odd, we cross. We have to hit our next point, which is at 2. At 2, the multiplicity is 3. The multiplicity is odd. Do we cross or bounce when the multiplicity is odd? We cross. And this is what the graph looks like. We don't know how high it goes. We don't know how low it goes. But we for sure know that it is a bounce. Now I'm going to give you another graph here. F of x equals to negative x to the fourth plus blah, blah, blah. Okay? We don't need to fill in the rest, but I'm going to tell you the roots are going to be 1, 1, 2, 2. So the roots are going to be 1 and 2. 1, when x equals to 1, the multiplicity is what? What's the multiplicity in this version? The multiplicity is 2. It happens twice. And for x equals to 2, the multiplicity is 2 also. Now take a look here. I wrote this problem that looks kind of similar to what we had before, except I changed the roots around. Okay? So let's go ahead and graph this and see how this looks. We'll come back to the other one in just a moment. Here's my graph. We have the roots at 1 and 2. 1 and 2. Dot, dot. What does the graph look like as we approach positive infinity? Now so 1 we did roots. 2 we do end behavior. What does the end behavior look like? As x gets closer to positive infinity, what's a positive times positive times positive times positive? Don't forget there's a negative in front. That's going to be negative, so we know we're going down. On the left side, this is negative infinity. What's a negative times negative times negative times negative? Don't forget there's a negative in front. Where am I getting this? Remember, you only have to look at the front. You only have to look at the front. Here, only look at the front. Get McDonald's? Yeah, we're going to get McDonald's. We are. Okay. So we know we're going to go down. Now, how are we going to go on this journey from left to right? As I'm walking through the park one day and I hit the root of 1, do I bounce or do I cross? That's fine. Take a look here. At x equals to 1, my multiplicity is 2. So do we bounce or cross when it's an even multiplicity? It is a bounce. Mr. Code, do I go all the way down to hell? No. We have to hit the next tick mark. We have to hit 2, right? That's our next checkpoint. We have to hit 2. So fine, I bounced off 1. I didn't make it through the ice. Came up to hit 2. Okay, 2. At 2, am I going to dolphin it out? Darn it, at 2, we also have a multiplicity of 2. It's even. That means we have to bounce again. So we bounce, right? We bounce off it, and we're coming back in the same direction. Oh my goodness. And we are exactly where we're supposed to. Okay, so I'm going to go through your My Open Math questions now, real quickly, so you guys can see what we're looking at. So let me pause this. Okay, here's a My Open Math class that you guys are going to be working on. And let me go ahead and just, so you guys can see it. All right, first question. Given the polynomial, they factored it for us already, right? They did the work for us. Thank you, Mr. Co. First question is, what's the y-intercept? Now the y-intercept is when x is 0, what's the y value? So just plug in 0. 0, 0, 0. Okay? What's 0 times anything? Let's see how that's a 0. What's 0 times anything? The first one's free. That's actually just 0 for everyone. Okay? Because there's a 0 there, 0 times anything is 0. Done. The x-intercept. So they want you to write the 3 x-intercepts, but careful, they want the smallest to largest. Okay? Smallest to largest. So the x-intercepts, looking at this, is going to be 0, 6, and -2. Take a look here. Are you guys okay with the roots? How I got the roots so quickly? Looking at the polynomial, looking at the factor form, my roots are what makes it go to 0. 0 is a root. 6 minus 6, -2 plus 2. Those are my roots. So writing smallest to largest, -2, 0, and 6 smallest to largest. Okay, looking at this graph, we have -2, 0, and 6. All right, look at the endpoints. Look at the endpoint. These are my endpoints, right? So you guys can see these are my endpoints. So what happens after 6? So that's the next question. When x is going to infinity, oh my goodness, what in the world? When x is going to infinity, here's infinity here. Are we going to go up or down? Are we going to positive or negative infinity? And that's what they want. They want you to write a plus or minus. That's it, plus or minus. So this is all you have to do. Just multiply x times x times x. See, these are just the front coefficients. The problem is actually x cubed. That's how this problem starts. P of x is x cubed plus blah, blah, blah. I have no clue. So x cubed. So what's a positive times a positive times a positive? Goes up. On the left, what's a negative times a negative times a negative? Right? Remember, aren't we all negative infinity over here? Negative, negative, negative is a negative going down. So read the question. When x is going to positive infinity, what's the y going toward? It's going to positive infinity. When x is going to negative infinity, what's the y? We said we're going to drop. How do I know we're going to drop again? Because a negative times negative times negative stays negative. That's it. You can do that in a minute. Okay. Let's look at the next question. Very similar to that. Now, what are the y-intercepts? Remember, we plug in 0 for y-intercepts. So that is -1 squared times -7. -1 is positive 1 times -7. That's going to be 7. That's it. When x is 0, what's the y value? That's what they want you to check. So at least we have one extra dot on the graph. And we have done that a lot more in class, but we're right now limited on time. Okay, what are the roots? What are the x-intercepts? That's going to be 1 and 7. Careful, they want us to write small to larger. That's 1 first and then 7. Okay, looking at these graphs at 1 and 7. Okay. What's going to happen to this? Well, didn't we say this is x squared? That's x squared times x is x cubed. Our front coefficient, if I multiply them all together, would be x cubed. So x cubed, positive, positive, positive is positive, negative, negative, negative is negative. And that's the end behavior for this graph. So as that we're going to the positive infinity, y goes to positive. As x goes to negative, see, x is in this way is negative infinity, y is dropping. Now you guys have a lot of questions here. Some of these questions do have videos, but let's go to this next one. This next one looks quite difficult, but let's go ahead and go through these types of questions. For the polynomial x cubed minus 5x squared minus 5 plus 5, okay? For this one here, find the end behavior of the graph using the linear coefficient test. So just looking at the front here, what does the right side and left side look like? So falls left to right, falls on the left but rises on the right, rises on the right, falls to the left, or rises on the left and right. Okay, so look at the term they use. They use fall and rise. So this one here is saying it's going to fall on the left and fall on the right. Next, the second question is fall on the left but rise on the right, rise on the left, fall on the right, or rise on the left and rise on the right. So that's the end behavior that they're trying to demonstrate. So for x cubed here, it's plus 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 will always be positive to the right. Negative 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 will always be down to the left. So which one does this match? This matches falls to the left, rises to the right. The graph is left to right. Yeah, it's left to right. That's right. But the graph will fall on the left side and it'll rise on the right side. I think that's what they're referring to. Okay, now the next part is they want us to find the x-intercept. So this part you will have to break down this graph. In this one, if I make this easy, it'll be 1, -5, -1, 5. The roots are only 1 and 5. These are our only possibilities, so it's pretty easy to find. Let's use I know the one's going to probably work with 5, okay? Let's plug in 5. And then it'll be x minus 1, x minus 5. That's 1, 5, 0, 0, -1, -5, 0. X squared minus 1, because there is no b term, there is no middle term. That's going to be x plus 1, x minus 1. So looking at the factors here, what's the roots? The roots are 5, comma, -1, comma, 1. Okay. Now, here is the part that you have to make sure you read, because this is the part that just asking questions. These are just asking questions about this. The behavior of the graph at all x-intercepts. If there is not an x-intercept with the given behavior, state D&E in the box below. Okay, so the question is this: x-intercepts where the graph crosses, and instead of me saying bounce, they say touches. Okay, so these are the two words that they use: crosses and touches. So these are about multiplicity. Do we have more than one multiplicity on our three answers? Do we have more than one multiplicity on our three answers? We don't. So these all cross. So we cross at -5, -1, and 1. That's what you would write. -5, -1, 1. Do we have any that just touch the graph, that bounce? See, they describe it as the x-intercept where the graph touches the x-intercept and then turns around. It's like your boyfriend is about to knock at your door and he hears your dad and he just turns around. Okay, this is a D&E. D&E does not exist. So that's what you would write, D&E. Okay. What's the y-intercept? The cool thing about this problem, the y-intercept is when I plug in x equals to 0. If I plug in 0, 0 cubed minus 5 times 0 squared minus 0 plus 5. Please, if you guys are looking for the y-intercept, it's just the last number. Because if I plug in 0, everything else goes to 0. That's 5. And you're done. Now, if you can do this, this is the big takeaway for this lesson, because you're going to do the same type of question over and over and over again. Over and over and over again. I wanted to make sure you guys are really good at this. Are the problems going to be hard to factor? Answer is no, they're not going to be hard to factor. Okay, over and over and over again. So yeah, a majority of these are different types of questions with different types of reactions. Let's take this one real quick because they actually did the work for us. Okay. Remember, you're not really doing that much math. Okay, now here, take a look. The end behavior of the graph. You know what? I'll get rid of some of these. You know what? I'll get rid of some of these where you have to factor. Okay, I'll get rid of some of these. Okay, I'll make them a little bit less. But on your test, you will have some of these. Like most of your test questions, I think will be related to this because I'm going to ask you to do the roots. Okay, this one's going to do the work for us. Now, what's the end behavior of the graph using leading coefficient test? Now, the leading coefficient test is going to be these guys here. But careful, that's squared. That's x squared times 2x is 2x cubed. 2x cubed, okay? 2x cubed. So if it's 2x cubed, positive, positive, positive means it's going to be up on the right. Negative, negative, negative means it's going to be left, down on the left. The x-intercepts are pretty cool in this problem because it's already all done. It's going to be 2. And here, 2x plus 3 equals 0. It's going to be -3 over 2. X is -3 over 2. Those are your answers. 2 and -3 over 2. So my roots are x equals to 2 and x equals to 3 over 2. But take a look here. We have a multiplicity going on. Multiplicity going on. That's going to be a multiplicity of 2 here and a multiplicity of 1. So where does it cross? It'll cross at 3 over 2 because it only happened once, but it will bounce at 2 because it touches. How to find the y-intercept? Plug in 0. Plug in 0. If I plug in 0, 0 and 0, that's negative 2 squared times 3. That's going to be 4 times 3 is 12. Okay. And these actually do the most of the work for you. Okay. All right. Okay. And that's it.